Alright, finally we come to the last task before Easter, which is about fuel cell. Okay, which is about fuel cell, and you should have watched the another video which is around 7 minutes first, then you come to this video. Otherwise, it will be difficult for you to understand what I'm talking about. For hydrogen fuel cell, fuel in normal time, when it is used as a fuel, then we burn it and then we ignite it, and then it will burns with fire, and then it provide heat energy. But now we use a suitable setup like this. We use a suitable setup like this one you can see now. Then the chemical energy will be converted to electrical energy, but not heat. But still, for the overall chemical equation, it's the same as that one for combustion. That means burning it like a fuel. For example, this one is a hydrogen fuel cell, right? So the overall chemical equation is just the reaction between hydrogen and oxygen become water. Of course, you need to balance it. And then we will consider the half chemical equation, the half equation. For example, oxygen. So what do you think oxygen will change to? As you can see, water is the only product, so oxygen will change to water. And according to what we have learned before, we balance it using the 3 steps, remember? But balance the number of oxygen by adding water, and then now there are 2 oxygen on the left, so there should be 2 water on the right. And then add hydrogen ion, and last add 4 electron. Okay, this is the half equation that you can see from the first video. And another one, hydrogen. What about hydrogen? Hydrogen gas. Hydrogen gas will turn to hydrogen ion. Okay, because just follow the 3 steps we have learned. There is no oxygen, so no need to add water. But add hydrogen ion, there are 2 hydrogen, so I add 2 hydrogen ion on the right, onto the right, and then add 2 electron. This is also another the equation you can see in the first video. Okay, just according to these 2 half equation, then I think you can tell me whether this one is the positive or negative electrode of this fuel cell, and also here. Okay, you should be able to answer me this question. And but for the fuel cell we are talking about in the textbook, it's hot concentrated potassium hydroxide. The electrolyte is an alkaline solution, so we need to turn this equation to alkaline condition. According to what we have learned, how can we turn it to alkaline condition? There are 4 hydrogen ion, right? So we will add 4 hydroxide on the left, and also add 4 hydroxide on the right. Then these 4 hydrogen ion and 4 hydroxide ion would change to 4 water. And for other things, I just copy it. Okay, not yet done. The last step, you have to simplify it. No more water, and then here deduct 2 water, so only 2 water left. Okay, you tidy it, and then it will be the half equation. And how about this one for hydrogen? Because there are 2 hydrogen ions, so I will add 2 hydroxide on each side to keep it equal to each other. The left hand side will equal to the right hand side. And the 2 hydrogen and the 2 hydroxide will combine to become 2 water. Okay, so it's done. So what you have to do is complete the overall chemical equation, and I think by looking at these 2 half equation, you can find out whether it is anode or cathode, right? And then you can find out whether it is undergoing oxidation or reduction. Do you still remember by considering oil rig and by considering red cat and os, right? And then one more question that one more point that you have to consider, which is KOH, the concentration of KOH. Look at the overall chemical equation here. Is any potassium hydroxide involved? No, right? So what do you think about the concentration of KOH, potassium hydroxide, when it is being discharged? The concentration of KOH will increase, decrease, or no change? So the voltage of the cell will increase, decrease, or no change. What do you think? Okay, and one more for the function of the nickel electrode, read it by yourself. Okay, and the advantage and disadvantage, I think you can read it by yourself. And one more thing I want to stress is, because hydrogen fuel cell, as long as there is hydrogen gas provided to the cell, then the voltage will be very stable, steady. So it is a very stable backup power source in hospital and hotels. Why? Because if the electricity suddenly goes out, then there will be no electricity for the life maintaining machines in hospital. Then the patients will die. That's why it is very important for the hospital to have a backup power source. Once the electricity go out, then they can supply the hydrogen to the fuel cell immediately. Then electricity will immediately go back to normal before the electricity go back to normal from the power plants. Okay, and also it is a power source for remote residential buildings, because when some people live very far away from the power plants, and then there's no electric wire, no cables to transport the electricity to these remote places, then they will use this fuel cell to get electricity. Okay, so I will show you what you have to do and the total mark of the assignment. So wish you have